So, so today what we're going to do is I'm more so going to go over the instructions for the fifth activity because I really want you guys to have practice with knowing the different, like doing the different, computing the differences between one sample Z tests and one sample T tests. So I want you guys to be able to go through this activity. There's a mix of both. There's both Z tests and T tests in there. So I wanted to give you guys that practice, but I was just going to initially, the meeting today is me essentially going over the instructions. And if you had any questions, I'll answer them, but then that'll conclude the meeting. So should be pretty quick today. So the fifth in-class activity is 6 questions. The first 2 are more understanding based. So I want you to explain the differences between the 3 research methods in psychology, the experimental, quasi-experimental, and correlational methods. Those are in like the very first lecture, statistics in a nutshell, and what can we determine from each of them. So this is just kind of a basic understanding as we move forward. As you move forward to take possibly 144, if you're a psych student, this will be something that's going to come up a lot. So I just want to kind of bring it to your attention now a little bit before you get too deep into it with 144. The second understanding question is one that we certainly have more experience with, more practical usage with in this particular class. So the difference between a population and a sample. I want you to answer that question as well as which is the most accurate, what's the point of taking a sample, how do we know if we're looking at a population or a sample, and then give examples. I know that we've done this before, or at least kind of talked about it for a few activities back where I wanted you guys to kind of explain to me, do your best to explain a concept that you're struggling with. Population and sample were on there. But now that we're doing the one sample Z test, and now this week the one sample T test, now we're starting to get an idea of why now it's a better idea as to why we need to know the difference between a population and a sample, because in order to do the calculations for our tests, we need to know which one is which. So just a little recap on that one. So answer those questions. And then the remaining 4 problems are a mixture of both one sample Z tests and one sample T tests. So as a quick little reminder between the differences between the 2 and the similarities, well, both of them are one sample tests. As the name implies, there's only one sample that you're going to see in a problem that would require a one sample T or Z test to calculate, to compute. So one sample is what they both have. And both of them are making the same conclusions. So keep in mind that for one sample tests, what we're doing is we have a population, like looking at just this problem in particular. So we have the average amount of Fs given on a daily basis is 3 with a standard deviation of 1.5. A sample of 100 college students was gathered. Their average Fs given in a day was 5.2. Okay, so we have population mean here with on average on a daily basis, it's 3, and the population standard deviation of 1.5. So on average, this is just the average amount of didn't mean to do that. That's just the average amount of Fs given on a daily basis in what's assumed to be the general population. So this is different. Now we have a sample of 100 college students. So that sample of 100 college students comes from the population of millions of college students, however many there are. So what one sample tests are doing is seeing if the population provided, this general population with a mean of 3 and a standard deviation of 1.5, we want to see if that population is equal to the population of the college students, the population that our sample belongs to. We don't have any information about the population of college students. We only have the mean, or excuse me, the sample size, and in this case, the mean of our sample here. So both one sample T test and Z test are doing that same thing. They are comparing the populations of the population provided as well as the population of the sample that's provided. So that's the overall conclusions that we make. Now, some of the differences that we have here is that for one sample Z tests, we're going to have the standard deviation of a population. That's the big key. Standard or z-tests are going to have the population standard deviation. T-tests will not have this information ever. For one sample t-test, instead, the standard deviation we have here is the sample. T-tests tend to have more information regarding the sample in general. And as we move further along in the next coming weeks, we're going to deal with the different types of t-tests, but all of them are very heavily sample-based. So t-test uses a completely different distribution, where the z-test, we use the z-table to find p-values, and we were able to use the standard normal distribution, the z distribution, to determine that. T has its own table, in which case the T table is telling us critical values, not p-values. So we would take those critical values and compare it to the test statistic, the T statistic we calculate in the third step of hypothesis testing that, calculate the test statistic. So degrees of freedom is also used for one sample t-test. Degrees of freedom is just kind of similar to how we had to overestimate our sample standard deviation and our sample variance in comparison to population, even when using the same numbers, all the same data points. Sample standard deviation, sample variance, sample variability is going to be bigger as opposed to population. Well, degrees of freedom is kind of us looking in that same concept being applied, since the T distribution focuses so heavily on samples. So to calculate degrees of freedom, we have n-1. It's just our sample size, so our 100, and then -1. I'm not saying this is a t-test. I'm not saying this is a z-test. I'm just saying this is the sample I have in front of me. So if we were to find the degrees of freedom for this problem, it'd be 99. Notice, though, that n-1 is very similar to our variance formula back in the day for samples. For population, it was just the sum of squares divided by the population size. But for sample, it was the sum of squares divided by the sample size -1. Again, identical to how we're calculating degrees of freedom, that sample size -1. So that's another thing to look out for t-tests. Yeah, so again, we use critical values to determine significance. T-tests also use p-values, but in terms of calculating them, we would have to do those through Excel for t-tests. Whereas with the z-test, we just refer to that z-table. So all of these tests that we're covering in the next few weeks, all of them use p-values, but we're not going to be calculating them since we'll need Excel to do so. But I do want you guys to know when we would reject or retain the null based on a p-value and alpha, just because that's going to be important to you. Not only for this basic understanding of statistics, but also if you move forward to any research methods class, you're going to be dealing more heavily with p-values. So I want that understanding to be there. All right. So for these problems, you'll determine which test you're going to use and then do the 4 steps of hypothesis testing. So again, state the hypotheses, set the criteria, calculate the test statistic, be it Z or T, and then make your decision. Will you reject or retain the null? So you'll do that for the remaining 4 problems. But that's it. I just kind of wanted to explain that. I wanted to go into some of the main differences between one sample z-tests and one sample t-tests, just to kind of prepare you for this assignment. I don't want to necessarily do the problems because, like I said, I really want the focus to be on your understanding, you getting the differences down. If I just tell you what they are without you practicing with them, I feel like that's not as effective. So that's our meeting. If you have any questions, feel free to email me. I know this assignment is due Monday. It's best to email me on Monday. I don't check emails on the weekends because I also have weekends that I like to enjoy and not work. So if you have questions, be sure to email me. The sooner the better on Monday, and I can get that response to you. But that's all I have. Exactly. Work-life balance is an absolute key, and I'm working on that the best I can. So that's all I have. Again, if you have questions, be sure to email me. I'll respond on Monday. But have a great weekend, everybody. I will see you next week. Bye.
Have a good one.
Thank you. You too.